look at elimination for solving our systems, and this will take 2 days. So we're going to take a look at when we add and when we subtract. So again, we have two equations with the same variable, our definition of a system. And if we take a look at our first example, I have x minus y equals 12. I have 5x plus y equals 0. We want to eliminate. Eliminate means cancel. So we've been doing inverse operations to cancel. Okay? And remember, if I want something to cancel out, they need to have the same value. Okay? So what I mean by that is if you have $5 and then you give me $5, they cancel each other out. All right, if I gain 2 pounds and I lose 2 pounds, I cancel them out. So in this problem, I want to look and find which one of my variables has the same leading coefficient. Hopefully you notice this has a 1, this has a 5. Those are not the same. This one has a 1 and this one has a 1. I'm not looking at the signs right now. Okay, they both have a leading coefficient of 1. What I want to do is now I'm going to look at those signs. Notice I have a plus and a negative. To cancel those out, I will add. So when I do this, that operation I decide has to be used for the entire problem. So x plus 5x gives me 6x. Negative y plus y cancels out. I'm going to put a 0 right there. That is not necessary. I'm putting it there so you can see it as a placeholder. 12 plus 0 equals 12. We could keep going, but we don't have to right now. Okay, we're going to finish an entire problem in a moment. We're actually going to do that problem in a moment. Well, what I want you to hop over to and look at the next one is I've got x plus 4y equals negative 6. I've got x plus y equals 3. Again, we look for the problem or the variable that has the same coefficient. I've got a 4 and a 1. Those are not going to cancel each other out. Doesn't matter if I add or subtract. A 4 and a 1 are not going to cancel each other out. I have a 1 and a 1. All right, same leading coefficient. But if I do 1 plus 1, they're not going to cancel out. In this problem, we are going to subtract. One of the things I usually talk about, and you'll hear me say in order to help you remember it, is S, S, S. All right, what that means is same, signs, subtract. So because both of these were positive, they had the same sign, we will subtract these two problems. X minus X, that eliminates. 4y minus y leaves me with 3y. And negative 6 minus 3 leaves me with negative 9. So you're going to have problems where we may add and where we may subtract. And it's very important that we pay attention to our signs in order to decide that. So when you have one of each, a positive and a negative, we will add. When we have same signs, we subtract, S, S, S. So let's go ahead and finish that first problem. All right, we're going to go through the entire steps. For us to use elimination, and this is the big thing that you have to get comfortable with. Right now, we did substitution, and then you had practice on substitution. Right now, we're doing elimination, and then you're going to have practice on elimination. Okay, we had graphing. You had practice at night on graphing. What we're going to get to is mixed problems, and I'm going to tell you to decide what method you want to use. and different methods work better with the style problem. Okay, so make sure that each linear equation is written in the form ax plus by equals c. That is our standard form. Okay, so when we were in slope-intercept form, we said graphing worked pretty easily. Okay, also substitution works when I'm in standard form. When I'm in slope-intercept form. When we have our equations in standard form, elimination is going to be our go-to. We don't want to have to convert if we don't have to. So we're going to do the x minus y equals 12 and the 5x plus y equals 0. That's the one we're going to do right now. Currently, both these equations are in standard form. I don't have to do anything to convert. Okay, so I'm going to look at step 2. Step 2 says to determine whether you will add or subtract all of the terms for the two equations in order to cancel out one of the variables. Okay, as we said, in this one we are going to add because the y term has opposite signs. Okay, so right now some of this looks exactly like we did on top, and that's fine. Okay, so we're going to go ahead and do it. We're going to use addition or subtraction. In this case, we already said we're going to be using addition, okay, because we have our opposite terms. So I have x minus y equals 12. Hold on. So we have x minus y equals 12, and we have 5x plus y equals 0. As we said, we are going to be adding this. I want you to make sure you pay attention to your work when you do it, because adding's, pretty easy to identify. One of the things I don't want you to get confused by is writing your subtraction and thinking it is a -5. Okay, so we're going to put a plus sign. I want you to put it far enough away that you realize it's plus for this entire problem. One of the other things you can do to help yourself remember that is you could also put some parentheses around it. So you realize that plus sign is separate from the 5. Okay, it pertains to the entire equation. All right, x plus 5x is 6x. Then we have -y plus y. Okay, that cancels each other out. We've got plus 0. Then I have 12 plus 0 is 12. All right. What that does is y is gone. I now am left with one variable. I have the remaining variable. I can easily solve for it now. I have 6x equals 12. That is a baby equation. That's a one-step equation. Divide each side by 6, which means x is 2. Well, now this should look a little similar to what we did in substitution. I have one variable solved. Now I can go ahead and plug it back in to solve for my second variable. So substitute it in to solve for my second variable. Again, it's up to you which of the original equations you plug into. All right, it's personal preference. So I'm going to go ahead and use x minus y equals 12. All right, don't have any leading coefficients that I have to deal with, which is why I chose this one. But as I've said in the last video and we talked about in class, it's not going to change your final answer if you chose to use 5x plus y equals 0. So in my x spot, I'm going to do 2. minus y equals 12. All right, I subtract 2 from each side. I have negative y equals 10. Well, remember, we never stop when we have a negative on our variable. We're going to go ahead and divide each side by negative 1. If you've been thinking, as I've been doing, negative or dividing by negative 1, could I not multiply by negative 1? You absolutely can. And I get y is negative 10. All right. Now what we have to do, as I've been trying to really drive it into your head, is I need to take those two answers and write my solution as an ordered pair, a coordinate point. So we have 2, negative 10. We're going to go ahead and check ourselves. Again, we check both equations. We have x minus y equals 12. And we have 5x plus y equals 0. Let's substitute and check it. X is 2 minus negative 10 equals 12. Minus and negative is plus. So 2 plus 10 equals 12. Make sure you finish, okay? So we know, yep, 12 equals 12. We're golden. Go to your second one. 5 times 2 plus negative 10 equals 0. 5 times 2 is 10. 10 plus negative 10, all right, goes along with what we've been talking about, eliminating. Look, they got opposite signs and we're adding them. So we get 0 equals 0. We know that our solution is in fact correct because it works for both equations. All right, you have some practice for tonight. I have you not only take a look at some problems and make the decision as to whether or not you should add or subtract, and then you have to go and solve those problems or solve some problems as well. Okay, so make sure you go through and practice, and we will go ahead and go over all this tomorrow, and then we have to do elimination with multiplication.